word a little bit, okay? One of the things I find when I teach that business calculus a lot of times is students kind of have some weaknesses with logarithms. We're going to just kind of look at it at a fundamental level. One of the reasons you learn about logarithms in business is because of finance and working with equations kind of backwards. Sometimes you have to work with logarithms a little bit. So I'm going to introduce you to something that you don't really in this class probably have to know that much about, what a one-to-one function is. And the reason I want to introduce this is because that's what a log is it's an inverse of a exponential function. So in order to understand that, you at least got to understand what a one-to-one function is, okay? So basically a one-to-one function is real simple. It's just, the best way to do this is like this. See if every y value has exactly one x value, okay? So it's kind of backwards of a function. So if you look at this example right here, there's two y values. These are the numbers in the range. There's three values in the domain. You ask the question, does every y have one x? Well, the 9 has one x. It goes to a 2. That's okay. How about the 5, though? What does it go to? It goes to 2 numbers. So that one is not one-to-one for that reason. Okay, you're doing it backwards. Back when I taught you about a function, you were taught a function, every x has exactly one y. This is a function. That 2 has one y. That's good. That 4 has one y. That's good. The 11 has one y. That's a function, but it's not what we call a one-to-one function. A one-to-one function, you ask the question backwards. Does that make sense? Okay, right? So you got to ask, does every y have one x and only one x? Okay, if you look at the next one, this is a function. Every x has a y. Every x has a y. How about one-to-one? Does every y go back to giving one x? Yeah, so one-to-one is like that. It's just you got 3 elements here, 3 elements here. They map 1-to-1. Every one y goes to one x like that. So that one is one-to-one like that, okay? So let's just do this kind of together. On this one right here, the domain is 1, 2, 3. Range is 4, 5, 6. Do you think that's one-to-one? Yep, it is one-to-one, okay? The 4 has 1x. The 5, 1x. The 6, 1x. So that's good. Okay, how about the next one? That's definitely a no. What causes the problem is this 2 has 2 x's. All right, so that's what makes it not one-to-one. So it's a special kind of a function. Now, we won't get too much into this because we want to kind of get right on into the idea of a logarithm. All right, so I'm going to talk roughly about what an inverse function is, and the purpose of that is to help you get some idea of where a logarithmic function comes from and what it's doing. So actually in an inverse, all you do is you just change the variables. All right, so in other words, you just, y becomes x, x becomes y. So all the variables just kind of get changed like this. So I'll show you kind of an example. And you don't need to write this down necessarily, but on this first problem right here, the inverse would just be this. Okay, we would just switch everything. So the domain would be 4, 5, 6. The range would just be the 1, 2, 3. So if we take everything backwards, that gives what's called an inverse of a function. X changes into y, y changes into x. That's all it is. Okay, and we'll kind of see this idea a little bit more carefully when we get into the logarithm. Okay, so go ahead and go to the next page and I'll show you what we're going to put together with this log function. Okay, now we've learned about exponential functions, and this is probably the simplest way that I can think of to give you an explanation of what a logarithm is to start with, is we learned, like last week, how to graph y equals 2 to the x. Okay? Now remember what we did is we did a table of values on that, and I've already got this table of values. I mainly want you to just kind of look at what everything I have here instead of writing stuff down on this. So when I do the exponential function, all I'm doing is I'm doing this. Okay, if x is 3, 2 to the third is 8. If x is 2, 2 to the second is 4, 2 to the first is 2, anything to the 0 is 1, And don't forget that 2 to the negative 1 is 1 over 2, so it's a half, and so forth. We learned how to do this last week. That's the graph of 2 to the x, and then if you plot these points, you get that curve that's being displayed in blue like that. That should look familiar to you. Does that look familiar to you? Okay, all right, that's that 2 to the x curve we did in section 2.5. So an exponential curve looks like that. Well, what a logarithm is it's an inverse, so everything is backwards. So notice everything got turned around. Negative 3 1/8, I just turned it around, and so forth. 3 8, I turned it around. So if you plot those points backwards, then you get this logarithmic curve, which looks like that. So that's what it is it's an inverse of the exponential function, so it looks like that. The other thing that's kind of worth noting is that these two graphs are symmetrical about that line. In your mind, does it look reasonable to you that if you folded the paper over that diagonal line that they would match perfectly? Okay, yeah, that's the idea. So what happens on this, you might write down just a couple of points. Like, for instance, this point right here is the point 3 8. That's worth writing down, and then this point right here is the point 8 3. So everything's backwards. That's what inverses are. Does that make any sense? Okay. Now, math is full of inverse functions. There's lots of things that we do one way and then do the other way. Okay. All right. So what we say on this then is this kind of develops what the graph of that logarithmic function is it's just the reverse of an exponential. At this stage, that's what you want to know. Okay, now what I'm going to do on this is we're going to develop the idea of a logarithmic function. And the first thing we're going to get comfortable with is this is the exponential form that you've already learned, like x equals b to the y. And if you do the logarithmic form, you write it like this. Things kind of get changed. The b becomes the base of the logarithm. The x becomes what you're taking the log of. Then you have the y like that. So the first thing you've got to learn how to do is how to interchange these into different forms. And once you do, then you can start making sense of what a logarithm is, okay? And one thing on a logarithm is the base. I'll explain why this is in a minute. The base has to be a positive number anytime that you're working with a logarithm. I'm not going to worry so much about domain and range right now. So what I want to kind of get you comfortable with first is this idea, then we'll start evaluating logarithms, okay? So it's actually very easy to do this. What I want to start with on this, these are all logarithmic equations. So what you're going to do is change them to exponential. So all you do is you do this. Think of it this way. That's the base, so that becomes the base of the exponent. The other thing that's worth noting is the answer. This is worth writing down. The answer to a logarithm is an exponent. Okay, I think I put that on the previous page and had that highlighted, but anytime that you're working with a logarithm, you're finding an exponent. So what this is this is the same as saying 2 to the 4th equals 16. That's the exponential form from that log form. So it's always the same. You just say that to that power equals that. Same thing here. That to that power equals that. This to that power equals that. That's what you're doing when you're interchanging those like that. Okay, so the answer to this one would be 7 to the 0 equals 1. And that's true. I try to give you a statement that's true. Okay, the next one goes like this. That's 9 to the 3 halves equals 27. Okay, like that. Now, I'm not going to go through too much in this particular class about what that 3 halves power means, but I'm going to just show you on a calculator what happens if I did 9 raised to the 3 halves. Your calculator will work this kind of stuff out. That just gives you 27. Okay, I'm not going to go through the y part of that yet, but what you're doing is just learning how to change the log form to exponential. That should be real simple. Everybody with me there? Okay. We also want to do this backwards. So you got 3 numbers. You just got to put them in the right spot. So here's the way I think of it. The base goes there. That just becomes the subscript of the logarithm. The answer to a log is the exponent. Then you got the leftover 9 like that. So you just got to put those 3 numbers in the right place. All right. Okay. Same thing with this one. Okay. What we'll do is we'll write a log The base is 4. That's what's being raised to a power, so that becomes the subscript. The answer to a log is the exponent, which in that case, that's 3/2. Then you have that leftover 8 like that. So just put the 3 numbers in the right spot, and then you got it. Okay? All right, the next one would go like this. We would say log. Whoa, why did I give you a log on that one? I don't know why I did that. Okay, scratch that out. Let's scratch that out and let me give you something better. Let's say you have 4, let's something simple. Let's say we have 4 to the 3rd equals 64. Okay, what I meant to do was give you a exponential function. So this would go like this. We'd have log base 4. The answer is 3. The answer is the exponent of 64. Okay, like that. So you just want to do those things backwards. To me, it's always easier for students to go log to exponential than this one. So that first row is simple. 2 to the 4th equals 16. 7 to the 0s equal 1. When you do it backwards, just remember the base goes there. The exponent is what it's equal to. Okay? So go ahead and just do those 4 problems down below. Just do that real quick, and I'll check you on that and make sure you understand what's going on here. Then I'll show you kind of how you use this to evaluate a logarithm. So the first 2 I'm just wanting exponential form, and the last 2 I'm wanting logarithmic form. And generally it doesn't take too long to do that. Once you get the hang of it, it's pretty simple to do. So what's the answer on number 1? There you go. 3 to the 4th is 81. That's true, too. 3 to the 4th is 81. How about the next one? Is that right? Okay, same thing. Now, one thing that you may or may not know is when you have a 1/2 power, that's the same as a square root. Now, that's worth writing down because you'll see that a little bit if you don't know that. So 16 to the 1/2 is the same thing as the square root of 16. Now, the square root of 16 is 4 because 4 times 4 is 16. Okay, some of you have seen that. Some of you maybe haven't seen that. Okay. All right, the next one. This goes like this. What you should have, what's the base? The base is 5. The exponent is what it's equal to. Then they have 25. And so you can check this and make sure you did it right on your right because 5 to the 2nd is 25. So once you change it to log form, in your head it's easy to tell you're right. Okay, the next one you would say log base 8. The answer is the exponent. You have the leftover 2 like that. Okay, now one thing I want to mention, you should write this down too. If you have a 1/3 power, this is the same as the 3rd root of 8. A 1/2 power is a square root. A 1/3 power is a cube root, and that's equal to 2 because if you multiply 2 out 3 times, you get 8. Okay, that's what that is. Okay, so if you have fractional exponents, that's just giving radicals like square roots and cube roots and so forth. Okay, all right. So at the bottom of the page, does anybody have any question about what you just did? Are we okay and comfortable with that? Because if you can't do that right, you can't do anything with logarithms. That's what it always comes back to, is that you can do that right. Okay, so we're going to do some logarithms in our head. One thing that I want to write down, you don't have to write this down because it's already on your notes, but again, this is real important. The answer to a log is an exponent. Okay, it's another way of writing an exponent. So really what this problem is saying is this. You don't want to get your calculator out for this. You want to do it in your head. What this problem is saying is 4 to what power is 16? You can do that in your head. What do you raise 4 to get 16? 2, exactly. 4 to the 2nd is 16. These problems are designed so you can do them in your head. Okay. The next problem, you're saying 2 to what power is 8? So what's that? That's 3. Okay. If you do 2 times 2 times 2, you get 8. That's what that's saying. Okay. The next one, this is saying 3 to what power is 27? You know what that is? That's 3 also. Okay, 3 to the third is 27. Okay, how about the next one? 6 to what power is 1? Do you know that? 0. Good, 0. Okay, remember that anytime you take something to the 0 power, you get 1. Okay, so that's what you're doing with a logarithm. It's a way of writing an exponent. This stuff was kind of developed hundreds of years ago to assist with calculation, basically. But there's all kinds of different applications for that. Okay, so I want you to do the next 4 and just see if you can do it in your head. Okay, they're designed so you can do them in your head. You got to ask the question the right way. And if you can ask the question the right way, then you should be able to get those okay. Remember, your answer is an exponent on all these logarithms. Okay, so again, what this one is 2, and all the question is on this is, the question is, what power of 5 is 25? So if you didn't write that down, I want you to write that down. This one is 1, that just means what power of 9 is 9? 9 to the first is 9. This one is 0, because it's saying what power of 10 is 1, and we know 10 to the 0 is equal to 1. Okay? And then this one is 5. This is saying what power of 2 is 32? The answer is 5 because 2 to the 5th is 32. And if you can't do that in your head, you can take your calculator and do 2 to the 4th and then 2 to the 5th until you find it. Okay? And we're not going to worry about the ones that you can't do in your head yet. You've got to do certain things on your calculator. Okay, is everybody okay with what I just had you do there? All right, that's really what a logarithm is. It's another way of writing an exponential expression, and you'll see when we get into the finance why logarithms are useful. At least for this class, that's what I want you to get a handle of. Okay, one thing is the log. If you just have log, that's a base 10 log. If you have ln, that's a base e log. So you want to notice on your calculator has 2 keys for logarithms. It has the log. Log is base 10, so it will do a base 10 log. So if I wanted to do the log of 100, and let me ask you this question before I press enter. What that means is 10 to what power is 100? So what is the answer? 10 to what power is 100? 2. Okay, so if I press enter, that's what I was going to do. It's going to give me the exponent 10 to the seconds 100. If I did something like the logarithm of 1, that's asking the question 10 to what power is 1? What do you think is going to come out? 0, exactly. Okay, but that'll only do a base 10 log, and the ln is only going to do a base e log. Those are the 2 most important logarithms that you work with. You can do other ones in a little bit different way, all right? So what I want to go ahead and run through is properties here and kind of work with some of these things. If you know the exponential form, then you can figure a lot of these things out without having to know these properties. But I'm going to go through and just kind of show you what the properties are. So we have the log base b of 1 is 0. Okay, the reason why is because b to the 0 equals 1. So if I take that logarithmic form and write it in exponential form, you get something that you know is true. Same thing with this one. If you take b to the first, you get b. So the log base b of the same number is always 1. We already did that a few minutes ago. Okay, this one's a little bit harder to see, but if you wrote this in exponential form, you would say b to the x is equal to whatever's left over. Okay, just all of these things, if you do exponential form, you prove to yourself why they're right. This is b to the 0 is 1, b to the first is b, this is b to the x equals b to the x. Did that last one make any sense? Some reason that kind of students don't see that right off the bat. This one I'm not really going to go through where this comes from. That's a property that shows up every now and then. We'll talk about what that is in just a minute. These other ones, I'll kind of talk about those after we do some of these basic ones. All right, so let me show you how you would do this. First of all, this is a base 10 log. If it's base 10, I'm not going to put a base 10. I just put log, so you got to know that. So you want to write down that that is equal to that. Okay. Now, this one right here, if you know exponents good, you could do this in your head. But what we're going to do on this is we're going to write this like this. We're going to write this as logarithm base 10 of 1 over 10 to the second. So I want you to write that like that. Okay? We've learned about negative exponents. So what we're going to do here is we're going to bring that to the top. And you want to write that as log base 10 of 10 to the negative 2. Okay, so what I've done is when you're doing a log of a fraction, typically you want to kind of work with it this way. Now, one of these properties would tell you the answer. I want you to look at these first 4 properties. One of those properties would tell you the answer automatically. Do you know which one it is? 1, 2, 3, or 4? 3, exactly. This says log base b of b to the x. It just says that's the answer. Okay, so that answer of that problem would be negative 2. Right? Now that's one way to figure it out with the property of log. And that's the way I'm going to try to teach this for now, is just learn the 4 properties, put it together that way. Okay? Okay, the next one goes like this. You have ln e to the negative 3. What you want to write on your paper is this is really log base e negative 3. Anytime I have ln, that stands for natural logarithm, so it's a base e. So ln, you won't see the base e, you have to know it is. Do you know what the answer of this problem is? Just like the last problem now. It's negative 3. So that's property 3, when you have log base b of b to the x. And see, the thing is, these things have to be the same. If they are, your answer is the exponent. Okay? So that's negative 3. Okay? How about the answer to c? Do you know what that is? It's staring you right in the face. 6. Good. Same property. All of these first problems are doing property 3. Okay? That's how that goes. All right? The next one, which property would this go with? Log base 7 of 7. 1, 2, 3, or 4? That's 2. That's property 2. Okay, so that one would just be equal to 1. You can do that one in your head. I had you do that a minute ago in your head. Remember, this just means 7 to what power is 7? Answer is 1. Answer to a log is an exponent. Okay, how about the next one? This says 3. It's kind of hard to see on your paper, but that's 3, and the exponent is log base 3 of 10. Which property, 1, 2, 3, or 4, does that go along with? What does it look like? 4. That's 4. Good. So what's the answer? What does property 4 tell you? It's this. It's whatever that is. Okay, so what is that? 10. Okay, that's 10. Okay? So that's just basically that property. How about the next one, ln of 1? Is that 1, 2, 3, or 4? That's 1, exactly. Okay, so that would be, anytime you do a log of 1, you get 0. And see what this problem really means is log base e of 1 equals 0. It's e to the 0 equals 1. That's why it's right. Okay, if you change that back to exponential form. So that's kind of what I'm wanting you to get comfortable with a little bit in this class is the properties. Okay, so let's go to this next page. We'll take a break. I do want to give you time to see if you can figure these problems out. Okay, and the properties, you may have to look back on the page. It's all going to be property 1 through 4 on these things, so you can take a look at those. I can maybe cut and paste and display this up here too if you need to. Okay, or I can just leave these up here and you can refer to these properties as you're doing those. Okay, let me see how many of these you can get. So just look at your properties and see which one it goes along with. So let's kind of see what we got on this. And what I want you to do is just put the answer in which property you have. So what did you get on A?
2.
You got what? 2. Yeah, 2. That one's that. Okay. All right. That one that's basically property 3. So it's good to put what the property is. Okay. How about the next one? What'd you get on B? 12. Okay. That's property, that's property 4. Yeah. Okay. So we got that. How about the next one? 0. Anytime you do the log of 1, it doesn't matter what the base is. answer is going to be 0. So that's property number 1. Okay. And see, you can check this one easily. You can check by just going 2 to the 0 is equal to 1. That number to 0 is equal to 1. Okay. How about the next one? What is the natural logarithm? What's the base? So it's a good idea to rewrite the problem that way. That's what you should do, is write it down that way. And then that would go along with property 2. So that answer is going to be 1. Okay. That one is by property number 2. Okay. And again, what it's doing on this is the way you can check your answer is just do exponential form. E to the first is equal to E. Anything to the first is itself. So that's why it's right. Okay. Anybody figure out anything on the next one? This is the one's the hardest. Anybody? I'll give you a hint. What's that? It is a negative number. That's good. Okay. Do you know what that negative number is? Well, let's see. Here's what you do. The 16, you want to write it as 2 to the 4th. I did a problem like this a minute ago. Write it as 2 to the 4th, like that. And then you can bring this up to the top. So you would get logarithm base 2 of 2 to the negative 4. Now what's the answer? There you go, negative 4. So you got to work with that in a little bit. Okay. So that when you're dealing with a log of a fraction, usually you got to work with the exponent like that. And then the last one, anytime you do the log of 1, that's 0. So that one would be by property 1, like that. Okay. All right, so that'll take care of that. What I mainly want you to know in this class, we don't have a lot of time to learn logarithms real in depth. So we're going to kind of just get you comfortable with the basic ideas and the properties. All right, so go ahead and take a 10-minute break. Come back and we'll wrap this up. Then we're also going to do 3-1 today. Okay, so for this level of a class, not going to really derive these formulas. I'm just going to demonstrate how they work. So what I want you to put in your calculator is just press your log button, and then let's just take two numbers and multiply. Like let's say 8 times 3 or whatever. You can pick two numbers if you want to try it, okay, or something different. So we're going to just do log of 8 times 3. I'll press enter. You should get that answer, about 1.38, okay? Now what I want you to do is do this, okay? Press the log button, press 8, close the parentheses, be sure you do that, and then add log 3. Now let's see if we don't get the same answer on that, okay? Look at that, it works. So what happens is, if you do a logarithm of a product of two numbers, you can just add the two things together. This thing hundreds of years ago was one of the things that made computations without a calculator, of course, a lot simpler. And it works if you generalize this, like if you did something like log of 2 times 3 times 4, that gives you that answer. Well, that's the same thing. That's 24. So if I did log 2 like that, and then plus log 3, whoops, got to close parentheses. Then I did log 3 and plus log 4, it'll give the same thing. So it doesn't matter how many things you're multiplying, they will still add up. Okay, so that's the first thing I want you to do. Now I want you to do this, okay? This time let's take the LN button. It doesn't matter, it works for all logarithms. Base E. Let's do something like 48 divided by 7. Something like that. Just put that in. Your calculator is going to figure it out. What it's doing is it's saying e to what power is 48 over 7. No way I could do that in my head. You get a bunch of decimals. Now I want you to try this. Do ln of 48. Be sure you close the parenthesis. Now do subtract ln of 7 and see if that doesn't give you the same answer. Okay? And it always does. So if you have a logarithm of a fraction, it's the same as just subtracting the log of the numerator minus the log of the denominator. Okay? Now I want you to do one other thing. Let's go back to the log button. Put in the log of 5 to the second power. Okay, like that. Now I'll show you another property. So just press enter. You get that. What that problem is saying is 10. Remember, log is a 10. 10 to what power is 5 to the second? Well, that's the power. No way you could do that in your head. Now do this. Do 2 times log of 5. and see if you don't get the same thing. Okay, and you do. Okay, so those are the three properties we're going to look at that are pretty simple, and there's a lot of times when it's necessary, particularly that last one. You'll do that all the time when you're dealing with financial formulas for different reasons. So here's kind of what you want to make sure you know. If you do the log of a product of two numbers, you can just add the two logs up. I demonstrated that a few minutes ago. If you do a log of a fraction, you just do the log of the top minus the log of bottom. If you have this situation where you have log base b of something to a power, that power just comes down in front. That's the last one that I had you put in your calculator. Okay, so as we do these problems, these are real easy to do, but it's just kind of an exercise to get you fairly comfortable with your calculator. All right, so let's go to these two examples here, and I'll show you what I want you to do. All right, so this one, we're going to do this in two ways. The first thing I want you to do is let's just do log base 2 of 4 plus log base 2 of 8. Now, we're going to go ahead and get the right answer, and we don't need a calculator on this one because you can do this in your head. Okay, remember, if you're doing this in your head, what are you doing? 2 to what power is 4? So what power do you raise 2 to get 4? 2. How about this one? What power do you raise 2 to get 8? 3. So that's 2, that's 3. Everybody got that? Okay, so when you put that together, this would be 2 plus 3, so the answer is 5. Okay, now here's another way to do it. You can do it this way. You could just multiply the 4 times 8 and get 32. Now, let's think about why the answer is still 5, because 2 to the 5th is 32, isn't it? Because if you multiply 2 out 5 times, you'll get 32. So you can do that either way, but it's real simple to do it that first way because the numbers are small and you can do that in your head. Okay? The second one, we're going to do this in two ways. What we're going to do is let's do log 3. Since it's a fraction, we'll do log base 3 of 81 minus log base 3 of 9. And we'll see if we can do this in our head. You may or may not be able to. It depends on your arithmetic skill. Do you know what power you would raise 3 to get 81? It's actually 4. It goes like this. 3 to the second is 9. 3 to the third is 27. 3 to the fourth is 81. How about this one? What power do you raise 3 to get 9? See, that's pretty easy to do in your head. So what you would have is this one would be 4. This one would be 2, so 4 minus 2 is 2. So that's the answer of the problem. Okay? Now, you could also do this problem this way. You could divide 81 divided by 9, so you'd have log base 3 and 9. Okay? What's the answer to this? 2, exactly, because 3 to the second is 9. To me, this problem is just as easy to do it this way. But both methods work. That's the property that you can do on that one, is just subtract those logarithms. Okay, the next one, we're only going to do this one way. I mean, you wouldn't want to do this the other way. I'll kind of explain why. So what you can do here is you can bring the 10 down. That would be 10 times log base 4 of 4. Okay, so that's a property that you can do. Now, can you tell me what log base 4 of 4 is in your head? In other words, what do you raise 4 to get itself? 1. That's 1. Good. So you would end up getting 10 times 1 would end up being equal to 10. Okay? Now see, these things right here, you can't do these on your calculator because they don't have a base 10 or a base e. So that's how you would do that. So again, with this first problem, we just broke it up. Since it's multiplication, we do log 4 plus log 8. Part B, since it's division or a fraction, we do log 81 minus log 9. And the last one, if you have that situation, you can bring that down. So go ahead and do those next 3 problems and see if you can do them in your head. I want you to use the properties. You're really doing property 5, 6, and 7 that are up here on the screen that are in your notes on the previous page. So just kind of giving you one of each of those types of problems. Okay, see if you can do that. The goal is to do these kind of problems in your head as much as you can. When you get to number 2 and you have that 343, you may have to play with your calculator a little bit. Depends on you. put together here. So this is what I'm looking for on this. This number 1, you bring the 3 down, so you'd have 3 times log base 5 of 25. And you want to do this log in your head. That log is 2 because 5 to the second is 25. Remember, the answer to a logarithm is an exponent. 5 to the second is 25, so you get 3 times 2, so the answer is 6. Okay? The next one, this was times, so you break it up like this. You say log base 7 of 49. Since that's times, you say plus log base 7 of 343 like that. Okay? What's log base 749? 2. How about the other one? You may have used your calculator. That was 3, wasn't it? If you do 7 to the third, you get 343. Just kind of experiment with your calculator. So 2 plus 3 is 5. Okay? And then the next one, since it's a fraction, you want to do log base 6 of 6, subtract log base 6 of 36. And you got to do it in that order. You can't do it backwards. So what's log base 6 of 6? 1. What is log base 6 of 36? 2, right? Okay, 1 minus 2 is -1. So that's your answer. Okay, so once you get everything set up, I tried to design the problems so those are logarithms you could do in your head. Okay, I want to kind of get you to that point, okay. All right, is there any question with anybody on that? Is that okay, what you just did? Okay, so the last thing that we're going to do here is we're going to solve some equations and kind of put this together. And a lot of this stuff is getting you used to this exponential form of a logarithm. So we're going to find whatever the variable is on these problems. So first of all, with this one, what you want to do, and you're going to do this on every one of these equations, is we're going to write in exponential form. That's the first thing that I showed you how to do. So what we're going to do is write this like this. We're going to say 4 to the third is equal to x. That's it. Okay, that's how you, when you solve a logarithmic equation, you write it in exponential form. Well, it's already solved for x. 4 to the third, you could take your calculator and just work that out. That would be 64. Okay, so the answer to that problem is 64. Now, here's why. You could check the answer by just doing this. Okay, we just found that the log base 4 of 64 is 3. The reason is because 4 to the third is 64. Okay, so we just write that in exponential form and solve whatever equation we got left over. Okay, so that's got to be 64 when you write that in exponential form. Okay, all right, next one, you do exactly the same thing. You say b to the second is equal to 1 over 25. Okay, we have solved this kind of equation before, and let me just make sure you remember this. What if you had x squared equals 9? What do you do to both sides of this type of equation? Square root both sides. Good. Okay, so that's what you're going to do. So we're going to do square root of both sides. All right, and any time that you do a square root of both sides, you get 2 answers. You get a plus minus. Now, one of them isn't going to work, and I'll explain that in a minute. So what you do, and you can do this in your head, anytime you do a square root of a fraction, you just do the square root of the top, square root of the bottom separately, right? So what's square root of 1? 1. What's square root of 25? 5, because 5 times 5 is 25, right? So we just get an answer of 1/5, okay? Not negative, okay? And the reason it's not negative is because the base cannot be negative, okay? That can't be a negative number, okay? Doesn't make any sense on a logarithm if that base is negative, okay? All right, so you're doing a square root of both sides to solve that. Does that make any sense? Okay. Next one, we got, this one's a little different. We're going to start this in the same way. You'll say 4 to the 3/2 power is equal to x. Now, I'm going to show you how to do this with and without your calculator. It's good to know how to do this both ways, all right? What this means is this. Anytime you have a fractional power, it goes like this. So that becomes what the root is. That's a square root. If that denominator was 4, it'd be a 4th root. And then you just put the 4 to the third like that. Okay, that's what that means. Fractional exponents are the same thing as roots. Okay, then you could do this like this. If you work out 4 to the third, you get 64, which you could do on your calculator. What's the square root of 64 in your head? 8. 8 times 8 is 64. The answer to that problem is 8. Okay? Now, the way that I'm starting every problem is the same way. You're writing an exponential form, then you're either working it out or you're doing something on your calculator. Yeah.
What happened to the 2?
The 2 on there became what the square root is. Now, when I went from this step to this step, you just don't need to write the 2 as a square root.
Oh, yeah.
But it means the same thing. That's why I just left that off. I could have certainly wrote that on there, though. Okay? All right. Next one. This goes like this. How do you write this in exponential form? We're doing that on every problem. We say b to the second is equal to 10,000. Okay? Now what do? Square root of both sides. Good. Okay? So what you're going to do is square root of both sides. You can take your calculator if you need to. All right? I just think of it as there's 4 zeros. Half of that's 2 zeros. So it's 100. Okay? 100 times 100 is 10,000. So that would be the solution of that problem then, like that. Okay? So what I'm doing is writing an exponential form and then taking it from there, either solving an equation or just figuring it out. All right? Does that make sense, what I'm doing? Most of this background issue stuff is going to show up in this section a little bit with exponents and stuff like that. Okay? So go ahead and see what you can do on the next ones here. Let's see how you do. Remember, you're finding the variable, but step 1 is to write that in exponential form and then take it from there. And when you see that number 2, notice I didn't put the base. You know why? Okay, if it's LOG, it's base what? 10. Okay, if that was an LN, what would it be? Base C. See, that's part of what I'm checking you on is little things like that. So that's really log base 10 of x equals 1. Write it in exponential form, take it from there. Okay, some of these problems you do in your head once you get them written out in exponential form. Sometimes you have to solve an equation of these things. So I'll just walk around and kind of see what kind of ideas I'm seeing there. Okay, that's good. That's good. Yep, that's good. 10 is the answer to that. Okay. You're good. Okay, you got everything. That's good. Okay, 9 is good. That's good. That one, 8 to the x is 64, and just see if you can figure x in your head. I tried to design all these problems so you can do them in your head. So you can't do it in your head, then it's a totally different kind of situation. So that one, just write b to the second equals 81. Solve the equation. So you got 9 there. And the answer to that's 10. Okay, because once you write that as, you would say 10 to the first equals x. So that's 10. Okay. Okay, those are good. Okay, so you're doing fine. Okay, that's great. Okay, that's not too bad. That one's 10. That's a base 10. So you'd say 10 to the first equals x. Okay. Got everything? Very good. Okay, those are right. As long as you know what you're doing in your head, I'm okay with it. Okay, so that looks good. And I'll do that, and then we'll finish up this page here. So basically what you want to do on all these problems is you want to write them in the right form. Write them in exponential form. Okay, so the first one, you just have b to the second equals 81. You can solve that equation in your head. So you have b is equal to 9. There's not a negative answer on that on the logarithm. That base can't be negative 9. Okay, this one is really log base 10x equals 1. So if you write it in exponential form, you'd have 10 to the 1 equals x. It's already solved for x, so the answer to that problem is 10. Okay, anything the first is itself. Okay, the next one, you say 8 to the x equals 64. Well, you can do that in your head. What does x have to be? 2. Okay, because it's designed so you can do it in your head. If you can't do it in your head and it's decimals, then you have no choice but to use your calculator. Okay, so it looked like we did okay. Okay, next thing, the last thing I want to kind of work on a little bit is this kind of log equation. And one of the things you're going to do is anytime that you see two logs that are added, we learned this a little while ago, you can put it into one log multiplied. Okay, we learned that. That's a property. The log of a product of two numbers is the sum of two logs. So this equation right here would be way hard to do in your head. But the thing is, this side of the equation, you have two logs added, so you want to put them together this way. So you want to write this as log base b of x plus 2 times x equals log base b of 24. Okay, like that. That's how you have to put that together, is like that. Anytime you have two logs added, put it together as a log of a product. Okay? Now, we have a property of logs. I haven't talked about this one yet. But if you have something like this, if you have a log base b of something equals log base b of something else, well then m and n have to be the same. You can actually take the logs off of both sides of the equation. You're not canceling them, you're just removing them. So what we can do is write this as x plus 2 times x equals 24. Okay, on the properties I had on a previous page, and let me run back to this just for a second, then I'll come right back. If you look at this property number 8 up here, that's what that's saying. If you have a log of m equals a log of n, just take the logs off. Okay, that's what that property essentially is saying. All right, now we're going to solve this equation. Now we have solved this kind of equation before, so hopefully it's just kind of a review. You're going to distribute, so x times x is x to the second. X times 2 is plus 2x equals 24. You have a second degree of quadratic equation, so you got to get one side set equal to 0. So what I'm going to do is just move the 24. When you do that, it becomes minus 24 like that. All right, what do you do next? Factor, good. 2 parentheses, you factor, excellent. Okay, so what we're going to do is when we factor this, we're going to have x times x to get x squared. The 24 has all kinds of possibilities. There's 1 times 24, there's 2 times 12, 3 times 8, 4 times 6. Which one's the right one? 4 and 6, good. Okay, I can tell you guys are getting faster at that, so that's good. What would be the plus one and what would be the minus one? Plus 6, minus 4. 6 minus 4 is positive 2. Okay, and now once you got that put together, then what you're going to do is you solve each equation. So you have x minus 4 equals 0. That would give x equals 4 as a potential answer. Then you have x plus 6 equals 0. So that gives x equals negative 6. Okay, now solving that equation, the only thing we did with the logarithm was step 1. We did that property. The rest of it is algebra done. Now there's one other thing that you have to check, and you'll see this when you start doing homework on this. One of these answers is right, one of them's wrong. So what you have to do, and you have no choice but to do this, you have to check these answers. So you want to write this down on your paper because this is super important. Sometimes both of them work, sometimes neither work, sometimes one works. So let's plug in the 4. So if you have log base b of 4 plus 2 plus log base b of 4 equals log base b of 24. Now you don't have to work that out. All you got to kind of do is see this. I'm going to go ahead and work it out. We would have log base b of 6 plus log base b of 4 equals log base b of 24. All right, now let me see if you caught on to this. What do you do with two logs added? How do you put them together into one log? Multiply, good. Okay, that's a property we learned. So that left side becomes log base b of 6 times 4 Well, that's the same thing as 24. That one works. So that one is a solution to the problem. Okay? Now we got to check the other one, and you have to, or you won't understand whether it works or not. So you want to write this down. We have log base b, -6 plus 2, plus log base b of -6 equals log base b of 24. Now you don't have to do anything else other than this. Okay, that thing right there is wrong. Okay, you cannot take a log of a negative number. And you want to write some sort of a note on that so it doesn't work. So really all you got to do for checking is you got to make sure that you're never doing a log of a negative number, because logs of negative numbers make no sense whatsoever. And I'll show you in a minute what I mean by that. So the only answer to this problem would be 4. You got to throw it out. Okay, and that will happen a lot when you're dealing with log equations. Okay, it's just the way it works out. Okay, one thing I want to go back, and you don't need to turn back here, but when we first looked at a graph of a logarithm, that red graph is a graph of a logarithm. Notice that it's always to the right of the y-axis. There are no logs of negative numbers. It doesn't make any sense when you construct that graph. So we're always going to have a log of a positive number when you're working with this. Okay. All right, let's go to this second one here. I'm going to erase what I did on the checking. I'll show you how to do this one. Okay, and again, you're looking at the properties. So let me see if we've caught on to this. How do you put together two logs that are being subtracted? As a fraction, exactly. Remember, there's a property that says, and you've done some of this, that would be the log of the first, x minus 1, over the log of the second, x plus 1. So you got to put it together. The last one we did the multiplication property. This one we do this. Okay, what's the base on that log? I didn't put it there for some reason. It's a 10, good. Okay, so that's a 10. Now after you do that, you want to write it in exponential form. So you would have 10 to the first equals x minus 1 over x plus 1 like that. Okay, so once you get it put together, do exponential form. All right, so that's going to give you 10 equals x minus 1 over x plus 1 like that. All right, now what you want to do with this one is, way back at the beginning of the semester, we spent a lot of time with solving equations with fractions. Equation has a fraction, get rid of the fraction. So I'd like to get rid of x plus 1, so I just multiply both sides by x plus 1. Now once you manage to do that, then you're home free. Okay, so you got an equation with a fraction, get rid of the fraction. Okay, so if you go to the left side, that would be 10x plus 10, and then that would be equal to x minus 1 like that. Okay, well, okay, what we can do here, we have variables on both sides, so I'm going to move the x over here, and I'm going to move the 10 that way. You can do that backwards of that if you want to. So I would have 10x minus x equals negative 1 minus 10 like that. Okay, so I'm just rearranging. That would give you 9x equals negative 11. Okay, and then the last step on the problem would be you divide by 9. So you would get x equals negative 11 over 9 like that. Okay, now we're going to have a problem with this. Okay, and this is one of the things you have to pay attention to on these problems. When you're solving a log equation, don't just stop. What you got to do is you got to take this thing and plug it in and make sure that you don't have a negative. So let me show you this. Okay, you're going to have a major problem on this. If you went through and checked it, if you did the log of negative 11/9 minus 1, just this part right here, that's a negative number. If you do negative 11/9 minus 1, it's a log of a negative. Therefore, you got to throw it out. Therefore, the answer is no solution. Okay, that's what I did on the last problem. You may be saying, all that work to find out no solution? Now, how do you know it's no solution unless you've worked it out? Okay, but you do have to go through and you have to verify that at the end. And all you look for is this. If you end up with a log of negative, throw it out. Does that make any sense?
So as negative, it's no solution.
Yeah, you cannot do a log of a negative number. Okay, like I'll show you on this. Anytime I take my calculator and do a log of any negative number, it's going to give you an error. It always will. You cannot do logs of negative numbers, okay? All right, so let me do this other one here. To me, what we're doing right now would be one of the more difficult parts of this section to manage. Okay, so we're going to do a bunch of things with properties on this. So first thing we're going to do is just bring down the left side, right? Now, what you got to do on this is we have a property. Remember, we had the property where you were bringing the exponent in front of the log. You remember that? Okay, you can do the opposite. You can bring something in front of a log and make it into an exponent. So what I'm going to have you do is bring the 2/3 and bring the 1/2 in as an exponent like that. So you'll write this as log base b of 8 to the 2/3 plus log base b of 9 to the 2/3, like that. Not 2/3, whoops, 1/2. And then minus log base b of 6 like that. Now that's a property. You're allowed to do that. You can bring the exponent down or you can bring it back up. Okay? Now let me kind of show you this then. All right? How do you put together two logs added? Multiply, thank you. Okay, good. Once you get this down, there's nothing to it. Two logs added become one log multiplied. So your next step, you want to write log base bx equals log base b 8 to the 2/3 times, times 9 to the 1/2, and then minus log base b of 6, like that. Okay? How do I write if I subtract two logs, how do I put them together? Division, exactly. Okay? So it's properties. You just keep bringing that down. Now we're going to get down to the point where we have log base b of 8 to the 2/3 times 9 to the 1/2 all over 6. Okay, so that's the properties that we worked with a little while ago, and you guys did a great job when I had you do some problems with these properties on it. You got to recognize it, and this problem is going to look a little more complicated to you. Okay, let me see if you caught on to this. I don't know. If you have a log on that side equals a log on that side, do you remember what I told you could do with the logs? Take them off, exactly. You don't really cancel them, you take them off. So what you would end up having is x equals 8 to the 2/3 times 9 to the 1/2 all over 6. And I'm going to show you how to work that out by hand. You can certainly do that on your calculator. Okay, those of you particularly going on, if you're going to take that calculus, man, you don't even know how to do all this stuff by hand. You're going to have to. So what we're going to do here is 8 to the 2/3. I talked about this a few minutes ago. That will be a third root of 8 to the 2nd. A 1/2 power becomes a square root of 9 over 6 like that. Okay? All right? So what you end up getting on this is this, and watch this carefully. The cube root of 8. What does the cube root of 8 mean? It means what number do you multiply out 3 times it gives 8? You know what that is? It's 2. So you would end up with 2, but then you would have to square that. So if you're doing the cube root of 8 to the 2nd, you really do it like this. You do the cube root of 8, which is 2, but then you do 2 to the 2nd to get 4. Okay, you know the square root of 9 is 3, so you get this. Now you end up with this. 2 to the 2nd is 4. You got 4 times 3 over 6. 12 over 6, 2. That's the answer, yeah.
Why can't you just do 8 to 2/3 instead of doing all the square root stuff? So you get the same thing. Like I got the answer, but I just multiplied, or I just did.
Did you do it on your calculator?
Yeah.
Oh yeah, you can do it on your calculator. But you are much better off. Students a lot of times when they find out they can do it on the calculator don't want to do it this way. But I mean, if you're going to go higher in math, you know, like the calc or something, you want to know how to do this. So what she's saying, yeah, you can do this. You can go 8 raised to the 2/3, like that. You can do that. Okay, that gave me the 4 that I had here. You can do that if you want to. Okay, so either way, I sure would like to be able to do it by hand. Okay, all right, try the next two, see what you get. Okay, see how far you go. You guys doing good. Logarithms are one of the major problem areas a lot of times with students in like a college algebra class. It doesn't have to be that way. Give it your best shot and see what you get. Okay, so let's see. This first one, you should have done log base b of x times x minus 4 equals log base b of 21. So you got to start that way. Then you take the logs off. So you have x times x minus 4 equals 21. Do a distributive property. You get x squared minus 4x equals 21. Get one side equals 0. So you get that. Okay. Do your factoring. Let's see. Your factoring, you should have got x and x, and you would have 7 and 3. Minus and plus like that, right? Okay. So I think you would have x equals 7, and you would have x equals negative 3. Which one is the bad one? And it's not because it's a negative answer. It's because if you plugged it in, you would be doing a log of a negative number. Okay? You can have you can get an answer to these problems that's negative. You can't, when you check it, you can't do a log of a negative. Okay, so this one really you should write down. This is a log base 10. You put it together like this, x plus 6 over x minus 3 equals 1. Okay, you write it in exponential form, so you'd have 10 to the first equals x plus 6 over x minus 3. Okay, now what do? You got a fraction, so what do? Get rid of it, exactly. So you want to multiply both sides by x minus 3. Okay, that'll wipe that out. Okay, do your distributive property, so that's going to be 10x minus 30. And then this side, you're left over with x plus 6. Okay, like that. Okay, then to finish it up, should be pretty straightforward. I would just move the x to the other side. Move the 30 to the other side. So you'd have that. So that looks like 9x equals 42. Did I miss something? Oh, you know what I'm doing? I'm thinking ahead. You ever do that? Yeah, sometimes. I think we all do. So this would be 6 plus 36. I did it again. Okay, 6 plus 30 is 36. Okay. Okay, so what I get is I get 9x equals 36. Then I divide by 9. And what do you get? 4. Yay, thank you. Okay. All right. All right, so we got through that. That's important. That's the sections that we're going to do from here on out is finance. So my finance will go smooth. You'll love the finance.